video we're going to be discussing the concept of compounding interest, okay? And so in order to do so, I think the best thing to do is to go ahead and start with just a situation that we can think about, a thought experiment. So we're going to start with this idea that we have a principal or a starting amount of money, we'll call it $100. Let's say we were able to put this into a bank account, and of course the bank is going to be using your money, so they provide you with incentive for using their money. They pay you an interest rate, okay, that compounds on your original sum. And so we're going to do a really make-believe bank here, but we say, let's say they give us a rate that is 10%. And then we can talk about what this necessarily means, okay? So we say, all right, since the bank, we say this is a 10% annual rate, since they get to use our money, what they're saying is one time a year, okay, annually, what we're going to do is we're going to take how much money you have in your bank account, which in this instance is $100, and we're going to give you 10% of that on top of what you started with. So let's kind of explore this. We say, okay, so P0, P sub 0, we're really referring to this as P at time zeros. The interesting thing is we say, okay, so we had $100. That is an initial amount. We started with $100. But what they're saying is that after a year, after 1 year, P sub 1, our principal at 1 year, we would necessarily say that it would be our original principal, P, plus some percentage of P. So let's say, of course, we wanted to find 10% of a number. I think this is a good time as any to point out that we want to change all of our percentage rates to decimals, but we necessarily say, okay, so we take our original amount, and they're going to add on an extra 10% of our original amount. That is, we could take our rate times the original amount to find that. So in this instance, we're saying it's $100 plus $100 times 10%. So we end up with $100 plus an extra 10% of what we had in there. So we say that'd be 10. We actually end up with 110 bucks. So not a bad deal. So we say, what if now we were to continue to compound this? So we say after the second year. Well, given the fact that now we have more money, we say we'd be taking our principal from the first year, or our amount with principal after the first year, okay, or after it's been compounded. We say $110 was our P1, okay, but we'd be adding on now P1 times the same rate. Okay, so in this instance, we'd say we had $110, and we get 10% of that 110 on top of what we started with. So now I've got 110 plus 10% of 110 is $11. Now we've got $121. Oops, thinking one thing, writing another. $121. So now this year went up $11, which is slightly more than the year previous. But if you think about this, if we were to continue these iterations for good, we say, okay, so P3 would be equal to, what we had at the end of the second year plus, what we had at the second year times the rate, which would be, okay, so 121 plus, 121 times that 10% rate, which would be $121 plus $12.1, and we end up, I think, with, let's see here, that'd be $133.10. Okay. But this continues to go on more and more and more and more and more. And every time it compounds a little bit more because we're starting up with more money than we had previously. So the intent of this video is to kind of expand upon this idea of compounding interest and really kind of come up with a general way to calculating how much money we would have after, say, so many compoundings per year for however many years. So let's take a look at this kind of pattern again. But essentially, the one really important thing we need to point out is this. If we start with an initial amount, say P is P, okay? And that's what our principal, it's what we started with. But we said our principal at the end of year one would necessarily have been our original principal plus P, or our initial amount, or principal, times that rate, okay? I want to take the time to say, now, notice that both of these terms right here have a P involved. We could factor that out. We say, so really, P1 was equal to P factored out times 1 plus R. And this is actually going to be very helpful when we start to go through other calculations, starting with, say, P2. They say, okay, so P2 necessarily would have been like P1, okay, our principal with interest at the end of year one, okay, times 1 plus R, okay, times 1 plus R. Or in other words, I just want you to see that if we multiply that out, that'd be P1 plus P1 times R, okay, which is kind of what we were doing over here. But essentially we say, okay, so P1 times 1 plus R, but we know that P1, recall that P1 equals this quantity. So instead of P1 right here, we could actually rewrite this as now P1, which was P times 1 plus R, times our extra now 1 plus R, and that'd be P times 1 plus R squared. Okay, so we say P2, we get this little quantity here. We say, oh, so P3 would have just been that P2 times now 1 plus R. Or in other words, I'll write this out for you. We say that's P2 plus P2 times that rate. Okay, so the amount we had last year plus that, the certain percentage of that amount on top of it. But we say, okay, so P2, but we know P2, okay, we found P2, and P2 is actually equal to this chain or argument here. We say, okay, this string, but P2 was now this, so we say P 1 plus R, and this was squared. Okay, so that's our P2 right there, times now 1 plus R. So really all that does is build in another 1 plus R. So now we've got P, our original principal, times 1 plus R cubed. Now I want to stop at this point and say, okay, so for our amount after the third year, we got P, our original amount, times 1 plus R to the third. We say if this were to carry on indefinitely, we'd say, okay, so given some P at any time T, so the amount we have at the end of any amount of years T, okay, would be given just by simply P times 1 plus R, okay, and we say to the T, okay. So what this really does represent is the amount of money we would have after so many years, or T, of compounding at a given rate R. So we say, let's come up with a formula here. We say, okay, so we say compounding interest. And we're going to formalize it here. And a few slight tweakings here. We say, so the amount A, okay, so we say A represents the amount of money we would have, okay, after, we say initially investing P, which was our principal, okay, it'd be our principal, and in parentheses we have 1 plus, now this is a little bit different, we say R over N, all to the power of N times T, where we've got R is being our rate is always a percentage, okay, and we say N. Now, N, for the first time we're seeing N, represents the number of compoundings. Okay, number of compoundings annually or per year. That's important. We'll come back to it. We say, okay, so T is a number of years, and it's always in years. Okay, so sometimes we have to have a fraction of a year, like 2.5 years would be 2 years, 6 months. But let's talk about N. Now, when we say number of compoundings annually, let's talk about a bank. We said in our first example over here on the left, this bank was compounding annually, which meant at the end of the year they would give us, say, 10% on top of what we had, but once a year. You have to know that there are other compoundings out there, so we say sometimes we talk about compounding quarterly. Quarterly would mean, that would be 4 times a year. We say, how about semi-annually? Semi-annually, well, annually means once a year. Semi means half, so this would be like 2 times a year. Okay, this would be 4 times a year, like we said. Or sometimes we say, how about monthly? So if we had something that compounded monthly, that would be 12 times a year. So this is what we're talking about when we discuss the N values. So how about we pursue a real quick example here? What if we said we had a principal amount of, say, $1,000 at a rate of 4.5%, and we say we're going to stash this money, and we're going to do so, and it compounds quarterly. So that's 4 times a year, and it does so for 5 total years. Okay, so for 5 years, they say 4.5% is $1,000. So we say, okay, so after this amount of time, how much money would we have? Now we've got a tool or a metric that's going to help us find this. So we say the amount of money we would have would be the principal, or 1,000 ducks, okay, times 1 plus. Now, we say this is R over N, where N was 4. But the important thing to note here is that R is a percentage. We need to change it to a decimal. So by shifting that decimal twice to the left, we should have 0.045. Okay, and this is all to the N times T. So we compounded quarterly, that's 4 times a year, times the number of years, and that was 5 years. So we end up with this expression. So really 1,000 seems okay. 1 plus, and we say okay, so 4.5. You know, 4 ways be 1 point. Oh man, I'm trying to think here. 1.125. Okay, so this is essentially, I think, 0.0125, and that's the 20th power. Of course, at this point, we'd use a calculator, but that's easy to do. So let's go ahead and pull out our calculator. We say, all right, let me clear this out. So we said initial amount was $1,000 times, in parentheses, 1 plus, now in parentheses, we had 0.045 divided by 4, end parenthesis, and this was all to the power of, okay, all to the power of 4 times 5. And hitting enter, oh, well, they want us to buy their calculator, but we say you would actually have, at the end of 5 years, you start with $1,000, you would actually have $1,250.75-ish cents. So 1250.75, so it'd be 1250.75-ish. So that wouldn't be bad. You actually you made a profit of $250.75 ish. Okay, so that's kind of how that formula works.